If you drive a modern petrol or diesel car built after 2018, its engine was intentionally engineered to pass strict laboratory emissions tests and then begin self-destructing shortly after your warranty expires. But implementing four simple mechanical survival rules can prevent a catastrophic £6,000 repair bill. Picture a shiny 3-year-old hatchback with barely 25,000 miles on the clock, sitting outside a house in suburban Britain. It still carries that fresh main dealer smell, the paintwork is immaculate, and the service book displays every stamp on time. Suddenly, while cruising down the M1 motorway, a red engine warning light flashes on the dashboard. It is not an orange maintenance reminder, but a flashing red alarm. Within seconds, the engine loses all power, the oil pressure drops to absolute zero, and by the time the breakdown recovery truck drops the car at a local garage, the mechanic is already shaking his head. The engine block is completely ruined, the crankshaft bearings have melted, and the repair estimate sits at £6,400. The car is 3 years and 4 months old, leaving it precisely 4 months out of its manufacturer warranty. This exact nightmare scenario is not a rare anomaly. It is happening every single week in independent workshops across the United Kingdom to honest motorists who did nothing wrong. These are drivers who paid tens of thousands of pounds for a modern car, booked every service on schedule, and trusted that engineering progress meant better reliability. What nobody ever told them is that under their bonnet sits an engine designed from its very first blueprint to be inherently fragile. For decades, buying a car meant entering an implicit agreement with the laws of physics. Classic four-cylinder engines, naturally aspirated 90s diesels, and rugged Japanese power plants were built with what automotive engineers call structural margin. They featured thick cast-iron blocks, generous clearances between moving parts, and lead-lined crankshaft bearings capable of swallowing a microscopic flake of metal debris without suffering damage. The engine oil was thick enough to coat every internal surface with a durable protective film. Those engines forgave missed service appointments, freezing morning cold starts in January, and long summer motorway trips carrying a heavy load. Reaching 150,000 miles was the bare minimum expectation, 250,000 was common, and 500,000 miles was repeatedly documented on engines that had never seen the inside of an engine reconditioning workshop. That era of automotive engineering is officially dead. Under the bonnet of a modern car sits something fundamentally different in almost every structural aspect. Manufacturers have replaced robust four-cylinder engines with tiny 1-litre 3-cylinder units boosted by turbochargers operating at extreme boost pressures once reserved exclusively for motorsport. The mechanical tolerances inside these downsized engines are measured in single-digit microns rather than millimetres. Spaces smaller than the width of a human hair separate components completing millions of high-speed revolutions during the engine's lifespan. To reduce internal friction and achieve low fuel consumption figures during laboratory government tests, car manufacturers now prescribe engine oils so thin they feel like water between your fingers. Specifications like 0W16 and 0W8 provide virtually no protective oil film under real-world operating heat and heavy acceleration. Furthermore, environmental regulations force the removal of lead from crankshaft bearings, replacing it with hard aluminium alloys that cannot absorb debris or forgive even a 1 millisecond interruption in oil pressure. If oil pressure drops for a fraction of a second in a modern engine, catastrophic metal-on-metal damage is instantaneous and permanent. The global automotive industry understands this reality completely, yet no manufacturer will admit publicly why they decided to build engines this way. The reason is not engineering incompetence. The reason is pure financial mathematics. Regulations enforced across Europe and the UK mandate strict fleet-wide carbon dioxide emission targets, imposing severe financial penalties of €95, roughly 80-some pounds, for every single gram of excess carbon dioxide multiplied by every single vehicle registered that year. A major car manufacturer selling 1 million vehicles that misses its fleet emissions target by just 5 grams per kilometre faces an automatic fine approaching £500 million. These are not theoretical numbers. They are the exact calculations sitting on the desks of chief executives across every major European automotive brand. To avoid these astronomical government fines, manufacturers were forced to squeeze tiny efficiency gains out of every mechanical component simultaneously, regardless of the long-term cost to durability. The result is a generation of downsized engines engineered to pass laboratory approval tests brilliantly and begin degrading rapidly shortly afterward. Before we examine the specific mechanical flaws destroying UK cars and how you can shield your own vehicle from them if you value this kind of unfiltered engineering truth that main dealers refuse to publish, take 2 seconds right now to subscribe to the channel and turn on notifications. By subscribing, you ensure you never miss upcoming investigations into hidden car repairs and practical motoring facts that keep money in your pocket. The most widely documented structural defect in modern European motoring involves the 1.2 PureTech turbo engine installed in millions of vehicles sold under the Peugeot, Citroën, Vauxhall, Fiat and Jeep brands. Engineers took a decision that sounded clever on paper. Instead of running the rubber timing belt externally in a dry housing as industry practice dictated for 50 years, they submerged the timing belt directly inside the engine oil sump. The goal was to reduce friction, lower operational noise, and save a fraction of a gram of carbon dioxide on test cycles. In real-world driving conditions, unburnt petrol vapor contaminating the engine oil chemically attacks the rubber compounds of the belt over time. The timing belt slowly degrades, shedding microscopic rubber debris directly into the oil supply. This rubber grit quickly clogs the delicate oil pump strainer, starving the entire engine of lubrication. The crankshaft bearings wipe out, the turbocharger seizes, and the entire engine destroys itself from the inside. While manufacturers eventually reformulated belt materials and extended warranties under intense public pressure, the underlying flaw remains structural rather than superficial. In other popular petrol and diesel models across Britain, the primary mechanical enemy goes by a different name: oil dilution. Motorists who use their cars for short trips, urban school runs, quick trips to the local supermarket or commutes under 5 miles are unknowingly destroying their engines. In modern diesel vehicles equipped with diesel particulate filters, the system cleans itself by injecting extra fuel directly into the engine cylinders during active regeneration. If a short journey ends before the engine reaches full operating temperature, that extra diesel fuel fails to burn. Instead, it washes down the cylinder walls and collects directly in the engine oil sump below. Drivers check their dipstick and notice the oil level actually rising over time, unaware that their sump now contains a dangerously diluted mixture of engine oil and raw diesel fuel. The oil viscosity collapses completely. The micron-level bearing tolerances lose their protective film, cylinder wall wear accelerates dramatically, and the engine seizes. When the owner arrives at the workshop, the manufacturer frequently blames the driver's short-trip driving style, rather than their own system design. Even brands famous for building bulletproof mechanicals have proven vulnerable to these extreme design limits. Major global manufacturers built on decades of legendary reliability have recently issued massive recalls involving metal debris contamination inside internal oil galleries and bearing failures on modern downsized turbo engines. When independent automotive engineers tear down these failed engines, they observe something far more concerning than simple factory assembly cleanliness issues. When specific crankshaft bearings fail systematically while the rest of the lubrication circuit remains clean, it indicates a fundamental issue with thermal management and oil pressure distribution. It means the engine was designed so close to its structural limit that a minor fluctuation in oil temperature or viscosity is enough to trigger total mechanical failure. When even historically bulletproof brands face structural engine failures, it confirms that the golden age of forgiving, long-lasting mechanical design is officially over. This fragile design cycle is compounded by official maintenance schedules, Main dealer service handbooks now regularly recommend oil change intervals of 18,000 miles or 2 years. Those long intervals are not engineering recommendations. They are corporate marketing tools designed to convince fleet managers and company car buyers that a vehicle requires minimal maintenance costs during its initial 3-year lease period. For a high-stress, downsized turbo engine running on water-thin 0W20 oil, an 18,000-mile service interval is catastrophic. Over thousands of miles, engine oil degrades, oxidizes, shear breaks, and becomes contaminated with fuel, moisture, and carbon combustion byproducts. It thickens when cold, thins out dangerously when hot, and loses its film strength entirely. The engine's delicate bearings cannot survive those conditions, causing invisible cumulative damage that culminates in total engine failure between 60,000 and 80,000 miles, conveniently just after the warranty has expired. To protect your car from this built-in obsolescence, you must adopt 4 practical mechanical countermeasures immediately. First, completely ignore the official 18,000-mile service manual interval. For any modern turbocharged engine, the absolute maximum oil change interval must be set at 6,000 miles or 12 months, whichever comes first. Replacing your oil and filter at 6,000 miles removes fuel contaminants and abrasive carbon particles before they can attack bearings or timing belts, instantly doubling the operational lifespan of your engine's bottom end. Second, make a strict habit of manually disabling the automatic start-stop system every single time you turn the key or press the start button. Every time a start-stop system shuts off your engine at traffic lights and restarts it 2 seconds later, the oil pump must repressurize the lubrication system from a complete standstill. During those first microseconds of cranking, the crankshaft rotates under metal-on-metal contact, protected only by a microscopic residual oil film. In heavy British town traffic with dozens of start-stop cycles every day, this repeated dry friction destroys bearing surfaces within a few years. Turning the system off preserves your battery, starter motor, and crankshaft bearings. Third, if your car uses a modern direct injection engine, arrange for a professional intake valve carbon clean every 25,000 to 30,000 miles. Unlike older engines where petrol constantly washed over the back of the intake valves, direct injection engines spray fuel directly into the combustion chamber. As a result, sticky carbon deposits build up heavily on the dry intake valves, disrupting airflow into the cylinders. This restricted airflow triggers dangerous low-speed pre-ignition knocking, which places immense shock loads on the pistons and connecting rods. Keeping the intake valves clean maintains smooth airflow and prevents premature piston failure. Fourth, once your vehicle passes out of its manufacturer warranty period, consult a trusted independent technician about switching to a slightly thicker oil viscosity specification, such as moving from a 0W20 to a high-quality 5W30 synthetic oil. Moving up one viscosity step restores a thicker, more durable protective film over internal components that operate under chronic heat and mechanical stress, providing crucial wear protection as the engine ages. None of these modern engine failures are the result of engineers forgetting how to build durable cars. Automotive designers are among the most capable technical professionals in the world. Modern engine fragility is the direct result of extreme regulatory penalties creating financial incentives that oppose mechanical durability, combined with commercial leasing models where a car built to last 300,000 miles makes no business sense for a manufacturer competing on fleet carbon targets. A car that lasts 20 years generates no replacement sales, whereas an engine that fails at 70,000 miles creates main dealer service profits, expensive spare parts sales, and ultimately forces the consumer to buy a new vehicle. Keep every single maintenance invoice, oil purchase receipt, and service record safely filed away in your home. That paperwork is your only legal protection if you ever need to challenge a manufacturer over a structural engine defect. Apply these 4 survival rules today, and you will keep your car running reliably long after others have ended up on the back of a breakdown truck.